Welcome friends. Today we will discuss about matrix, mainly geometrical interpretation or physical interpretation of matrix. Let me consider any matrix A is equal to let me consider any matrix A is equal to 1 2 3 4 and now evaluate the dead value of the matrix, which is 4 minus 6 is equal to minus 2, not equal to 0. So A is non-singular. Det A not equal to 0 means A is non-singular matrix. Now let me draw the curve. This R2 plane, R plus R, R2 plane, X, Y. So we plot this vector. We plot this vector 1, 3 and 2, 4. So 1, 3 means approximately we take 1, 3. So 1, 3 vector. So this is the 1, 3 vector. Now consider 2, 4. So 2, 4 will be in this area. So 2, 4 matrix is 2, 4 vector is this 2, 4. Now observe the position of carefully observe the position of the vector. This is called position vector. Both are in different place. 1, 3 vector is this, and 1, 2, 4 vector is this. So this is their position is different. So that's why this matrix, constant matrix, is not equal to 0, non-singular. Let me consider a singular matrix, that is 1, 3 and minus 1, minus 3, minus 1, minus 3, minus 1, minus 3. Now first we plot 1, minus 1. So 1, minus 1. This is the vector 1, minus 1. Now we plot 3, minus 3. So where will be the 3, minus 3? 1, 2, 3, 1, 2, 3. So three minus 3 will be on the same line. 3 minus 3. So we see here, when a matrix is singular, that is det is equal to 0, then there means this means the vectors must be collinear. The vectors must be collinear. The vectors in the matrix, forming the matrix, must be collinear. Collinear means the vector lies on the same plane, same straight line. The vectors lies on the same straight line. Now consider one more C. Consider another matrix. C is equal to 2, 3, minus 1, 2. So date C is equal to 4 plus 3 is equal to 7, not equal to 0. So what you can say about the vector 1, about the vector 2 minus 1 and 3 2. What you would say, 2 minus 1 and 3 2, they are non-collinear. Why they are non-collinear vector? Because the matrix, because the determinant value is not equal to 0. If I plot, so first we plot 2 minus 1, so 1 2 minus 1, so 2 minus 1 vector is, and another vector 3 2, so 1 2 3 1 2, 3 comma 2. So you see both the vectors are non-collinear. Both the vectors are non-collinear. So vice versa, we can say if any two vector, vice versa we can say if any two vectors, suppose this one vector, we take one vector and called it A. We take another vector on the same line. We take another vector on the same line, same straight line. Suppose this vector is B. So O P Q. So OP is A vector, OQ is B vector. Then the two vectors forming the matrix, then this the matrix forming by these two vectors, AB, if I call it P, since they are collinear, means they lies on the same straight line, so the date value of P must be 0. That is, the matrix must be singular matrix. This is as well as applicable to 3-dimensional also. I am, for sake of simplicity, I am taking 2-dimensional 2 cross 2 order matrix. So if we take any vector, this vector called, I call it A. If we take another vector, we call it C. Then the matrix Q forming C A is the matrix forming by these two vectors must be non-singular. This is the concept, geometrical concept of the matrix or rank of the matrix. So when rank of the matrix is less than the order of the matrix, then the vector of the matrix must be collinear. So thank you. Like, subscribe and share.